Hello, welcome to Chapter 5, Section 1, Graphing Polynomial Functions, Day 1 Notes. We're taking all of Section 5.1 and splitting it up so that you're getting little bitty chunks at a time. So the first thing we're going to do is talk about what's called a polynomial. You've seen polynomials before. We've talked about quadratics, linears, constant functions where it's just a number. But we've never called them polynomials, but that's what they are. That's what they're called. They're called polynomials because it's a sum of monomials, which is just one term. Okay, and so we need to make sure that we give these things names so we can talk about them amongst each other. A polynomial function is a function of the form f of x equals a to the n, x to the n, plus a sub n minus 1, x to the n minus 1, and so on until you get a constant. Now, the requirement is that the first, the leading coefficient, that's the first coefficient of the equation, is not 0, and the others are that the exponents have to be whole positive numbers, and the coefficients have to be real numbers, right? It's not helpful if it's imaginary. They have to be real numbers. The first term is called the leading coefficient. Now, it's not always the first term there, and we're going to talk about that, but it's the one with the highest exponent. It's the coefficient in front of the one with the highest exponent. I'm going to show you what that looks like. N is the degree of the polynomial, and that's the highest power. A sub 0 is the constant term, and the reason it's the constant term is because it has no x value. So if you were to look at it, right, it's by itself, right? It's a constant. It's a constant term. It tells you the y-intercept because if you were to take 0 and plug it in for all the x values, you would get just that number, right? Because all of the other terms will have an x in it, and they'll all disappear. Now, you have to write it in standard form in order to really see what's happening. So you have to make sure that it's in standard form, which means that the exponents go from the highest to the lowest as you move from left to right, right? So if you have a fifth power, it'd be fifth, fourth, third, second, first, none, right? And whatever you're missing, that's fine. You just have to make sure that they're all in order. They don't all have to be there. So these are examples of the different types. You have constant functions, which is just a number. Linear functions, which would be like 5x plus 2, right? We've seen that. We've dealt with that. Quadratics, 3x squared plus 2x plus 5. Cubic, x cubed plus 5x plus 4. Now look at that one, right? It's missing an x squared. That it's still cubic, right? It's still a cubic function because the highest exponent is 3. That's what makes it a cubic function. And we call this a cubic trinomial. And the reason it's a trinomial is because, like I said before, there are 3 terms. In the first one, f of x equals negative 12, that is a constant monomial because there's only one term. For linear, the linear example, 5x plus 2, that is linear binomial. Okay, so that's how you say all that stuff. After quartic, so quartic is the last one with a special name. After that, you just say fifth power or sixth power or whatever. So let's go ahead and deal with some of this stuff. So first we have to decide if each function is a polynomial or not. So negative 4x to the fifth plus 7x squared minus 2. That is a polynomial because all of the coefficients are whole numbers and real, and all the exponents are whole numbers and real, and they're all just added together. And it's just exponents. So yes, it is a polynomial. It's already in standard form because it goes from 5 to 2 to nothing, right? And so that's exactly what we need it to do. So we don't have to change anything. The degree is the highest exponent. The highest exponent here is 5, right? And we put it in standard form, so it happens to be the first one there. So it's a degree of 5. So we're going to call this a fifth power. And there are 3 terms. So 1, 2, 3, which means that this is a trinomial, right? Because tri means 3. The leading coefficient is just the number in front, so that'd be negative 4. Make sure you include whatever sign is there. The y-intercept is this negative 2 back here, because if you plug in 0 everywhere else, everything else will go away. Next one. Is this a polynomial? Yes, because all the exponents are positive whole numbers, and all the coefficients are real numbers. So it doesn't matter that they're decimals or roots. They're real. So it still works out. What this isn't is in standard form. So let's go ahead and change it. I want my leading coefficient to be the one that's with the highest exponent. And that would be the fourth power. So I need to change the order here, right? Because I need to swap those. So, and then plus 19. All right, so this is a quartic. Oh, the degree is 4. So this is a quartic. And again, 3 terms, so trinomial. The leading coefficient is the square root of 3, right? Because that's what's on the fourth power. I rearranged it so that it would be the leading coefficient, but that's always the leading coefficient because you always have to look in standard form. And then the y-intercept is the number that's left over, so that'd be 19. C, we have negative x cubed minus 4x to the negative fourth power. That is a problem. That means that this is not a polynomial because that's not a positive whole number. It's a negative whole number. So this is not a polynomial. We don't have to answer anything else about it. X squared plus 9 to the x minus 1. This right here, that is called an exponential function, which is not a polynomial. It's not part of it. It has to be ax squared or ax to some power, right? It can't be a number to a power of x. That's not the same thing, so still no. All right, now, we need to be able to look at an equation, or I'm sorry, look at a graph, and determine what that leading coefficient is, or not necessarily what the number is, but whether it's positive or negative. So when we were talking about quadratic functions, if it opened up, it was positive, and if it opened down, it was negative. And we knew that just based on that first term. And we can do the same thing with any function. What the difference is that now we're not just talking about everything up and everything down. If it's an odd function, it's going to go off to the right and down to the left, up to the right and down to the left if it's positive. It'll do the opposite if it's negative, up to the left and down to the right. So think about it as the positive side should be positive, right? Which means that if I'm going to the right, it should also be going up. That's what makes it positive. If it's not doing that, then it's negative. Now, like with exponential, like with quadratics, for even powers, they're either both going up, which makes them positive, or they're both going down, which makes them negative. And we did see that when we were talking about quadratics. So, let's, oops. Oh, and then we have local maximums and local minimums. And we've talked about a maximum and minimum before, but before there was only one. Now there can be many, because we're talking about polynomials. There could be so many different ways that it could go up and down, that there can be relative maximums and relative minimums, or local, whichever word they use, they both mean the same thing. And a local maximum just means that it's that highest point, like right here. It means that everything around it is below it. And then the local minimum would be down here, because everything is above it. Now, endpoints, those aren't relative max or min because they go on forever, so they don't count. All right, so let's go ahead and look at a graph. So, first, we need to determine if the degree is even or odd, and that's actually really easy to do. If it's even, they're both ends are going in the same direction. So if we look, this end is going up to the left, and this one's going down to the right, which means it's not even, it's odd. So it's odd. And it's because the ends go in opposite directions. So now we have to determine if it's positive or negative. Now, like I said, if it's to the right, ideally, it would be positive. So because as I go to the right, as I go this way, my function is going is going down. Okay, which means that it's not going to the right and up like it should be. It's doing what it shouldn't be doing, which means it's negative. Okay, so the answer is that it's negative because it's going up to the left and down to the right. How many real zeros are there? Now for zero, zero is just another word for x-intercept, right? Which is another word for solutions, which is another word for all those other things. So all we're looking for real zeros is where it crosses the x-axis. So 1, 2, 3, 4, 5. So it crosses 5 times. So there are 5 real zeros. Then it's asking for how many relative extreme values there are. That's including max or min. So let's find the min and maxes. So we've got a min down here, 1, all the way up here to 2, 3, 4. Right? So it's where it changes direction, where it's going from increasing to decreasing, or decreasing to increasing. So that's just 4. And that's really easy to see if you're just looking at the equation, at the graph. Now, like I said, when we're talking about solutions, there's zeros, there's factors, there's solutions, there's x-intercepts. They all mean the same thing. And when we dive into solving polynomials, which we will get to, don't worry. When we get there, we will end up factoring or doing some other method to try to figure out what those zeros are. But we need to be able to identify them just on a graph, which, like I said before, is really easy to do. You're just looking at where it crosses the x-axis. So in this case, it'd be here and here, right? It can just touch the x-axis as well. It doesn't have to go through it. So the solution would be -2 and 0, because you're only going to write down the x values since the y values clearly are just 0, right? Now when we look at an equation, just like we did with quadratics, we have to take all of our factors, set them equal to 0, and solve for x. Now with a polynomial, naturally there are going to be more factors because there are more exponents. So we have to get used to that. So let's go ahead and take each one and set it equal to 0. Now remember, -2x, that's a factor. So if -2x equals 0, x equals 0, right? Because when you divide by -2, 0 divided by anything is still 0. Now we have the x squared plus 4. Let's set that equal to 0. So x squared equals -4, right? When I move it to the other side, we take the square root. When you take the square root, you get 2 answers. You get plus or minus the square root of -4. Now, we have the square root of a negative number, which means the square root of 4 is 2, but the square root of -1 is I, which makes this a not real solution, so we don't count it. Okay? We want to see how many x-intercepts it would have, and if it's an imaginary solution, it doesn't actually cross the x-axis. Now if we look, x plus 9 and x plus 9, those are the same. So because there are 2 of them, we only have to do it one time, and we're going to get the same answer for both of them. So x plus 9 equal to 0. We subtract 9, so x equals -9. That's one of our answers. And then finally, x squared minus 2. Okay, so we add 2 to both sides, so x squared equals 2. We take the square root, which means how many answers do we get? 2. The positive and the negative, right? You'll find that things that we learn in the first semester don't disappear just because you're in the second. And then because it's plus or minus, that's actually 2 different answers, right? We have the positive version and the negative version. So when I count it, we have 1, 2, 3, 4. So there are 4 real solutions, or 4 x-intercepts. Now just to tack this on at the end, it's actually not very hard to evaluate, right? Evaluate just means take the number and plug it in. Because if you see this notation right here, f of negative 5 means that instead of f of x and having x's in your equations, you have negative 5's in your equations. So for f of negative 5, we're going to take this and replace all the x's with negative 5's. Now, be careful. Don't forget, when you plug things in, you put it in parentheses. If you don't put it in parentheses, you will probably get something wrong. Now, negative 5 squared is 25, so we have negative 25, because you apply this negative afterward. Negative 7 times negative 5 is positive 35, and then minus 5. Well, negative 25 plus 35 is 10, and 10 minus 5 is 5. So that's it.